Hey guys, thanks for tuning in and welcome to a very exciting episode of the Bohemian Machine. You know, ever since I bought the lifeboat, I knew that with that much windage and a single screw, I was really going to need a bow thruster. It's just a whole lot safer and less stressful maneuvering in and around marinas with very expensive boats. And so, as I started looking into the traditional types of bow thrusters, just like anything specifically marine, it's outrageously expensive. I mean, yeah, there are some cheap ones, pretty low powered, but anything, name brand that's got a decent amount of thrust is just thousands of dollars, and this isn't a complicated piece of equipment. It's an electric motor driving a shaft through usually a 90-degree gearbox and a propeller. Ain't all that much there. So as usual, I start looking to the automotive, RV, and industrial fields for similar products, and there really isn't much. And what I first imagined was just constructing my own from raw parts, only with a trunk containing the shaft of the motor that was higher than the waterline of the boat. So you could pull all the components out and clean and service everything without having to remove the boat from the water or dive down to even get to the prop to clean it. And I couldn't find any commercially made examples of something like that. They're all really short and unserviceable with the boat in the water. And so then I kept thinking about different configurations and drive mechanisms. So I had to really start thinking well outside the box for something a little more creative. And so, since I've already got this kind of exoskeleton thing going on here, and I want to add a bow pulpit, I thought, well, why not hang it on the outside and just drop it down when you need it, so it's out of the water the rest of the time. Easy to get to for servicing or cleaning, and I mean, it really can't get any uglier. And so I knew this setup was going to work, and for a beta version, much more desirable than cutting two big holes in the bottom of my boat. And one of the biggest stumbling blocks was the gear setup. Now, traditionally, you have a motor with a vertical shaft to a right angle gearbox. Finding a cheap right angle gearbox is not as easy as you might think. So I'm thinking of alternatives to that, simple, cheap, and what about chain? Motorcycles have been using chain for over 100 years, and it seems to have worked out pretty well, even carrying hundreds of horsepower. So now all I need to do is build like a long chain case and something to mount the motor. And so I'm making drawings of aluminum pieces to bolt or weld together, and something kept nagging at me, and there has to be something already made, something I can just use. What could it be? What could it possibly be? I mean, what's a long, slender, waterproof chamber that I could run a couple of links of chain down and then put a 90-degree housing at the end for a shaft? So here's what I got. Number 35 chain, that's like go-kart chain. And these little 9-2 sprockets. So that will fit inside an 1.5-inch pipe. And so 5/8 shaft, also from go-kart stock with bearings. I grooved out for a keyway here to fit the sprocket, and then these bearings were cheap, so I decided just to double them up. Why not? And then this will all fit in this. The Schedule 80 is a little beefier and a little bit wider. And then these adapter caps will go on the end. The bearings will fit inside in the inner part. With this as a bushing, this is a fitting for underwater well systems, but it's just the right size to fit in that. And then the bearing fits in here. I had to hone it out a little with a Forstner bit. And then these seals will go in here after sizing that with another Forstner bit, and I'm going to double up on those. And so then dual props. Okay, so the Forstner bits did not work well in resizing this PVC. Even in the drill press, they wander pretty badly, and my holes are not centered all the way through. So I got some sink tail pieces that are pretty much exactly the right size. They fit in here tightly with just a little gap around the outside, which I'm gonna fill with some good old JB. First, I'm gonna get these seals installed in here. A little bit of sealant in there to help. With the lips facing out, both of them. Pack a little grease in here. Now that that's set up and this is cut off to length, I can press the bearings in. So now it's just time to glue this last cap in and thread the chain through, and then I still can access my Allen screws to center everything up, and there's a stopping collar there, and I can tighten that up so there is no end play on the shaft. This thing almost puts itself together. And initially I was trying to find a design that could be taken apart so I can service it, but you know, these bearings are sealed. I can lube the chain from the top, and really, since it's not living in the water, it really shouldn't need any maintenance. And if the bearings go bad in 20 years, you know, I'll just build another one of these. So get out the glue. So there you have it. Pretty much ready to go. Time for the chain. Now to tighten up my set screws on the sprocket and the locking collar. So then for the motor end, I had this starter motor. It's a permanent magnet motor, so it can be run both directions. That's from a big Yamaha outboard. But then I found this big hog online. That's a replacement motor for a worn winch. Advertised at 6 horsepower. It was only like $100, which should be massive overkill, but hey. And so then got a 6-inch drain pipe fitting that will fit into, and I've got made some adapters down to 1.5 inches. Got another 9-tooth sprocket that fits this shaft, so now I just need to mount this in here where the sprocket's centered. Okay, so fast forward, it's mostly together. This is the winch motor fitted into a 6-inch drain pipe adapter. Bolted into a 1/2-inch PVC plate, fastened inside, and this is my go-kart chain heading down to the props. And then this is a special repair sleeve that slides in and out with an O-ring inside to keep the water from leaking. It's meant to do repairs where you don't have the ability to move the pipe in and out, so you can slide it back apart and glue it back together. In this case, it allows me to take the slack out of the chain if I ever need to. And then this is what holds it in place. It's just a rubber repair sleeve with hose clamps on it. And this is a couple of stainless exhaust clamps that I'm making up with a PVC sleeve inside. And this will actually be the locating mount. But I do have a hanger here at the top that's bolted into the motor. And this will take the weight and allow it to slide up and down. And I'm hooked up to a battery here with a relay pack, and I'm gonna fire it up. And you can see it was moving some air there. So it should push some water pretty good. And so then to get this mounted on the boat, I used some Schedule 80 PVC pipe, heated and flattened on the ends to put some bolts through. And some bushings mounted to the motor housing so it can slide up and down and still be stable. These caps are just pushed on here. They fit pretty tight. This one I put a little piece of weather strip on, but it's not taking the UV, so I'm going to try to replace that with an O-ring. But I don't think it will leak anyway. Couple of pulleys. And a linear actuator.
Oh. We are fast.